Okay, I'm going to explain to you a couple things about taking measurements in this part of the lab. You already went through a process where you talked about the appropriate starting point, reference points, things of that nature, but I'm going to show you how to take a few measurements. One is the height of the puck, and then one is the distance and time that it travels on this horizontal section. All right, to get started, what I want to do is open the toolbar, which is right here, up here in the upper right-hand corner. The first thing I'm going to place on here is a horizontal line. You can see it's right here. And that horizontal line is going to go down here at the bottom of the track where the puck is traveling at a constant velocity. Now, in order to see that point, I'm going to have to scroll this baby ahead a little bit so I can find out when it is at the horizontal section. So I'm going to scroll ahead to here. And you can tell exactly when it's at the horizontal section because the puck is horizontal. So right there, it's still at a bit of an angle, so it's not at the horizontal section yet. So right there is when it's at the horizontal section. So I'll slide this line up till it's right in the center of the puck. Remember, it said the center of mass, which is something we haven't studied in detail yet, but it's basically the geometric center of that object. So there it is. That's my reference line. So that's zero height for me. Now I'm going to reset this and put it back at the top. If I want to measure the height, I need a reference point up here. So I'm going to click on this dot up here, this red dot. When I click on that, a red dot will show up here, and I need to move that to the center of mass of the puck, which is there. And then I can measure the height of that puck above this reference line. I'll use the vertical ruler to do that. This is how you turn it on right here in the upper right-hand corner. And I'll line the zero line on this ruler, not the blue part, not the bottom of it, but the zero line up with my reference line. So you can see it's lined up perfectly there, but it's too far away from the puck. So I got to slide that baby over here by the apple, and that looks pretty well lined up. And I would say this is at 25, 26, 26 and a half centimeters. So some of the questions in here refer to units of centimeters and some refer to the units of meters. So in this case, you're going to use centimeters because that's one of the questions, or you will sometimes answer in centimeters. If that was the case, this would be 26.5. If we were measuring in meters, it'd be 0.265 meters. Right. So that's measuring the height of the puck. The next thing that we could do here, I'll toggle this off by doing that. If I were required to change something at this point, like change to a new height, I would click down here on the lower left-hand side. You can see where it says change, hopefully. I'll click on that, and you can see I have these options here. Right now I'm at height K, way down here. I could change this to height A. You can see that it makes a really dramatic change. I'm also going to change the mass here to show you what that looks like as well. Look at the size of this puck right now, and look at the location of it. Now when I load this, the puck is now way down here. This is height A. This is going to be one of the heights that you will measure. And you'll notice how much bigger the puck is. This is if you have mass 2, because some groups or some people will have mass 1, some people will have mass 2. That's randomly generated depending upon when you open the lab, and that's what it'll look like. So I'm going to go back to height A or height K that I started with. So that's where I have everything set up. I'll go back to mass 1, and so here's where I am. My reference line disappeared, bummer. So I'll put that back on here. Though I technically don't need it because I've already measured the height. What I want to do now is measure the speed of the object as it hits this section down here. And right there is where it starts traveling at a constant velocity. So one of the questions talks about that. So I want to find out what frame that is when it starts traveling at a constant velocity. So that's right here. So I will go up here to the stopwatch. You can see this stopwatch opens up this neat little window in the middle. It's got a time, it's got a frame on it. So the frame where this thing starts traveling at a constant velocity is about frame 141. So that's how I would answer that question. When it stops is over here, and I can go frame by frame if I click on this little forward arrow here. So it hits the person's hand pretty much there. So I could say 159, 158, somewhere in that region. When you type those answers in, there is a little bit of a built-in uncertainty. So if you don't get the exact correct number, you'll still get credit for it. So that's my those are my times for that. Now let's say that I'm trying to actually find the speed of this thing. I'm going to back this up to where it started traveling at a constant velocity, and you can pick pretty much any 2 points along here that are decent distance apart from each other. But let's say I want that as my initial point where this travels at a constant velocity. Since this is where I'm going to initially look at it, I'm going to record this as 0 time. So I'm going to click that and make it a 0. And I want to measure the distance it travels in a certain period of time. Since that's a horizontal distance, I'll click on the horizontal ruler and I will line this up somewhere on this puck. So you have choices as to where you want to line this up on the puck. I'm going to pick the back edge of the puck. And the reason I'm going to do this is because that edge doesn't hit the person's hand. It should be a little easier to see that when it gets toward the end of the motion of this object. So right now I'm at 0 position, 0 time. Perfect starting spot. So I'm going to click forward here until this thing gets to the person's hand. And I don't want to keep it going here. See how it's already hit and it's kind of bouncing backward. It's moving around. I want to go to the very instant, maybe even right before it hits the hand when there's a little space in there. So you can see there's a tiny space between the person's hand and the puck. I'm at a time of 0.0625. And this puck has moved 10, 11, 12, 13, 14 centimeters. So in my data table, I would type in a time of 0.0625 and a distance of 0.14 meters because we want to measure everything in meters per second on the data table and in the graphs. So again, that's 0.0625 seconds, and it would be a change in position or a distance of 0.14 meters. The way I have the data table set up is that it will automatically divide those two numbers and calculate the velocity. Now, we can use that really simple equation, velocity is distance divided by time, because the object's traveling at a constant velocity here along this section. We don't have to worry about any accelerations. We can use that very, very simple equation because the object has a constant velocity in this section. So that's basically how you're going to collect the data. You'll go through, you'll change the heights. So I'll go to, you can work from K down to on your way down, or I think on the data table I started with A. You do whatever you want as far as the process of filling those in. The data table, like I said, goes from A through K. Just please make sure that you put the right numbers in the right spots. At this point, I can measure the height again. Like I said, I can slide this point down to the center of this. To click this forward to make sure that my reference line is still lined up okay. And still looks good, right? So I go back to where this puck started from. Boy, this is going to be pretty low distance, pretty low height. So I'll put the meter stick or the measurement device on here, line the 0 up with the horizontal line. Let's say it's about 1 centimeter. Yeah, so my height for that is 0.01 meters. And as I mentioned, we'll now be able to measure the distance it travels. So I'll get this up to where it's moving at a constant velocity, which should be about the same spot right there. Well, that's nice how that lines up again. I'll reset my time to 0. So now I have 0 position, 0 time. And I'll let this click forward. It's not going to be moving nearly as fast. You can see it's taking a lot longer to get to that person's hand. You don't necessarily have to make it move the entire way to the person's hand. I'm actually going to make it easy on myself and make it to right there, because that's exactly 12 centimeters, and that's a time of 0.25 seconds. So my time would be 0.25 seconds. My change in position would be 0.12 meters, and I'm ready to go, and I can collect the rest of the data. So this should be a pretty quick process for you. Once you collect the data, you've got some analysis to do, and hopefully you'll gain some understanding of energy in the process. By the way, make sure that you're using the correct mass the whole time you're doing this, because some people will use mass 1, some people will use mass 2, and make sure when you do all your calculations toward the end of the lab that you're doing everything in meters, kilograms, and seconds. Okay, if you need to rewatch this video, you can do that to help yourselves out. Good luck.